Hello and welcome to this video tutorial on modeling security risk using graphs. The tutorial is targeted to security professionals as well as anyone is interested in knowing more about security risk modeling. This tutorial will give you the basics to model security risk using graphs. We will first introduce you to the CORAS graphical approach to identify, communicate and document security risk. We will also explain you how to evaluate security risk. At the end, we will present an online banking scenario that you will analyze during the experiment. Now, let's introduce the CORAS graphical modeling language. CORAS is a method for conducting security risk analysis developed at SINTEF, a research institution in Norway. CORAS provides a graphical language for threats and risk modeling. The language provides a graphical symbol for all the standard concepts. This table represents the main concept of the CORAS risk modeling language. The first column denotes the concept. The column in the middle denotes the definition, while the last column reports the graphical icon used to represent the concept. Let's start with the concept of threat, which is a potential cause of an unwanted incident. In CORAS, there are three different symbols for denote a threat. A threat can be a human with a malicious intent, represented by the devil's icon in black, or it can be a human that accidentally harms the system under analysis, represented by the white man here with the stop sign. A threat can also be an event that is outside control of a human, that is represented by the white flag here with the stop sign. Then we have the notion of vulnerability, that is a weakness or a flaw that can be exploited by a threat to cause harm or reduce the value of an asset. A vulnerability is denoted by a red padlock. A threat scenario instead is a series of events that is initiated by a threat that may lead to an unwanted incident. A threat scenario is represented by an oval with a stop sign on top. An unwanted incident instead is an event that harms or reduces the value of an asset. An unwanted incident is represented as a rectangle with a yellow lamp sign on the top right corner. An asset is something to which a party assigns value and for which it requires protection. An asset is represented by a bag of dollars. A treatment is an appropriate countermeasure to reduce the risk level. It is denoted by a green tool chain. An unwanted incident and a threat event are usually associated with a likelihood and a consequence. The likelihood represents the frequencies or the probability of an unwanted incident or a threat scenario to occur, while the consequence is the impact that an unwanted incident has on an asset in terms of harms or reduced asset value. Now let's give a look at a CORAS model. The threat customer in this model initiates two possible threat scenarios. In the first scenario, the customer exploits the vulnerability, lack of compliance with terms of use, to initiate the threat scenario customer shares credential with next of kin. In the second scenario, the customer exploits the vulnerability negligent customer to initiate the threat scenario customer keeps credential on post-it note, which leads to the threat scenario credential revealed to third party. Both scenarios lead to the unwanted incident unauthorized account login, which impacts the asset integrity of account data and user authenticity. The risk of an unwanted incident at authorized account login is given by the likelihood that it occurs and the impact that it has on the asset, integrity of account data, and user authenticity. The likelihood of the unwanted incident unauthorized account login is labeled on the unwanted incident. The consequence instead is specified on the error that links the unwanted incident to the assets. To reduce the risk, we need to mitigate the two threat scenarios. The first threat scenario, customers share credential with next of kin, is mitigated by the treatment regularly informed customers of terms of use. The second threat scenario is mitigated by the treatment informs customers of security best practices. Now let's see how we can assess the level of risk of an unwanted incident in terms of its likelihood and consequence. The risk value of an unwanted incident is computed based on a risk evaluation matrix. The metric has as rows the possible values that the likelihood can assume, while it has as columns the possible value that the consequence can assume. The entry of the map instead represents the risk levels. The risk levels denoted in green represent the risk that can be accepted. The risk level denoted in yellow, orange are risks that need to be monitored, while risk denoted in red are risks that needs to be treated. So it is necessary to identify a treatment to reduce the level of the risk down. Now let's introduce the home banking scenario that we will analyze in the rest of the experiment. The online banking scenario focuses on the online banking services provided by Poste Italiane to their customers. Customers can access their bank account information through the Poste Italiane application or through the Poste Italiane mobile application. Customers can perform operations like checking their mobile balance, checking their credit cards, or topping up their mobile phone. The assets to be protected in this scenario are the integrity of account data, which includes personal information as well bank account information, user authenticity, which means that the person that is logged in as a user is identical to the user, confidentiality of customer data that protect personal information of the customer from unauthorized access, and availability of service, which means that the online banking service has to be available 24/7. This concludes the tutorial on modeling security risk using graphs. Thank you for your attention.